name is Lykke-Hartmann. I'm at the Department of Biomedicine in Aarhus University in Denmark. So I'm a scientist, and I've been working in science for many years. I've been very dedicated to using mouse models to ask biological questions. So about 10 years ago, I was joining a big research team at Aarhus University, and we started planning to do some mouse modeling of the sodium pump. One of the mouse models that we have created is a knock-in mouse model which harbors the D801Y mutation. That mutation was initially associated with patients suffering from RDP, but has now also been found in a patient with AHC. So what are we doing with this mouse model? I mean, the first sort of many years was to establish the line and to establish some of the symptoms that we could find in this mouse. So this mouse captures symptoms that we see typically for RDP, but we also have things that we can recognize from AHC. And many of these things has been very valuable for me to discuss at these ATP1 alpha-3 symposiums, where we can really try and translate as much as possible from a mouse model into a human disease. Of course, there's many limitations, but different models offer different sort of advantages and, of course, disadvantages. So why are we doing this? Well, because the sodium pump is very essential for the function of all cells. The alpha-3 gene is very essential for neurons, and neurons are very essential for our central nervous system and how the brain works and how we live from that. So we have been spending most of our time, as I mentioned, to just look at this model. What do we see? What kind of symptoms does it capture? And what can we use this model for? And what I think would be really valuable now to head is to really figure out each of these symptoms that we see. We really have to associate with a very specific cell population in the brain, saying that these cells are the mediators of this certain behavior. And when we can see this correlation, I would really like to try to apply some kind of rescue on that cell type to see if we can reduce or rescue the phenotypes that we observe corresponding to symptoms that are seen in patients. And one of the ways we would really like to address this is using some stem cells therapies to see if we can replace the cells that are not functional. Maybe some gene therapy as well, to try and see what is the advantage between one system to the other. Maybe we could do it sort of in a developmental term as well, saying if you target the mice very young versus if you target them as adult. And I think this would really show us what we can do, and perhaps in the long term, I know that maybe short term as well, but it's when you're working in a mouse model, of course, it's not directly translatable to a human, but I think this is something that at least can be very useful for our understanding of this. So towards this goal now, we have established our first sort of experiment on this field, and we are publishing, and as most of us know, we need publications to get funding and granting. So I think right now I'm really ready to apply for funding, and I'll be really looking for people who would like to work with me, with stem cells applications and gene therapy applications in mouse modeling. So I think this has great potential for understanding the pathology of the disease.